For decades, enterprise software was built on static code, but we are now deploying probabilistic systems, software that operates on statistical likelihoods and actively changes its own pathways without human intervention. Standard compliance frameworks like ISO 27001 for information security were engineered to govern systems with fixed logic. A specific input yields a specific, testable output. Machine learning removes this predictability. Systems rely on training data, resulting in decision-making that is non-transparent and non-explainable. This is compounded by continuous learning. Because an AI updates its behavior dynamically during use, its outputs drift over time. This drift means a static security audit is effectively obsolete the moment a live model begins interacting with new data. IT leaders and compliance officers lack the tools to govern systems they cannot explain using rules for predictable software. Governing artificial intelligence requires a specialized oversight architecture engineered specifically for volatile, self-modifying systems. ISO IEC 42001-2023 provides the global requirements for this missing oversight. It outlines the specific steps for establishing and maintaining an artificial intelligence management system, or AIMS. ISO 42001 moves beyond voluntary ethical guidelines by establishing a certifiable framework that demands documented evidence of control. An AIMS is a set of interacting organizational processes designed to achieve specific risk and compliance objectives. Think of an AIMS as a structural wrapper. It is designed to contain and document the non-deterministic nature of the AI core by encasing it with layers of organizational context, risk assessment, and technical controls. We are going to reverse engineer this standard and build a compliant AIMS, layer by layer. Adopting this standard allows an organization to translate vague mandates into a precise, auditable chain of evidence for executives. We begin building the outermost layer of our AIMS model with Clause 4, Context of the Organization. An AI system does not exist in isolation. An organization cannot assign specific security controls until it defines its precise legal and operational role in the AI supply chain. The standard identifies distinct roles, differentiating the responsibilities of organizations that produce foundation models from the customers and partners who simply deploy them. Once the role is established, Section 4.2 requires the organization to formally determine the expectations of all interested parties. In traditional IT, interested parties usually meant internal stakeholders. For AI, that definition expands to include data subjects, regulators, and even the external groups affected by a model's output. Effective risk management starts with defining exactly where the organization sits in the supply chain and who is caught in the model's potential blast radius. The middle layer of the AIMS architecture is Clause 6, Planning and Risk Assessment. This is where ISO 42001 diverges from prior standards by mandating a parallel, dual-track assessment engine. Track 1 is the standard AI risk assessment. This focuses on the consequences to the business itself, such as financial loss or operational downtime. Track 2 is known as the AI System Impact Assessment. An impact assessment forces organizations to document the potential consequences the AI system has on individuals, groups, and societies. This covers qualitative external damages, like algorithmic bias, loss of privacy, or physical safety risks to the general public. Crucially, the standard requires that the results of the external impact assessment be fed directly back into the internal organizational risk assessment. This structure binds the organization's internal risk profile to the external harm its AI might cause to society. Once the risks and impacts are identified, the organization must perform formal risk treatment to mitigate them. Annex A serves as the normative control matrix that organizations must use to treat these identified risks. Annex A requires detailed documentation of all resources, specifically calling out the quality, provenance, and characteristics of the training data used. These controls extend through the entire engineering lifecycle, requiring specific verification and validation phases before a system is deployed. The organization must review this entire matrix and explicitly justify which controls it implements and which it excludes. The ultimate output of this phase is the Statement of Applicability. The Statement of Applicability acts as the definitive ledger for auditors, linking every identified risk to a specific control. Annex A transforms high-level concerns about AI safety into a list of specific engineering compliance checkboxes. Maintaining an AIMS requires continuous operation to match the ongoing mutation of the AI core. Live data from the deployed system continuously feeds back into the organization's performance evaluation and internal audits. If an internal audit flags an unexpected change in the AI's behavior, it triggers a formal management review. This review dictates corrective actions, which update the core policies and recalibrate the risk models. ISO 42001 creates a closed-loop, self-correcting system capable of governing continuous learning technologies. The utility of this standard lies in its ability to provide a harmonized, global language for AI governance. For IT leaders, assuming that existing quality or information security frameworks will cover machine learning is a significant liability. Organizations should move past high-level ethics pledges and begin conducting a gap analysis against the controls in Annex A. ISO 42001 establishes responsible AI as a measurable, auditable engineering standard.